Hello everyone from Math 1435. It's Pre-Calculus 2. Professor Wenson here again with a video on the KnewtonAlta homework for section 7.2 part 1, titled The 6 Trigonometric Ratios. So I'm just going to go straight into the KnewtonAlta homework. Hopefully you know how to find the OpenStax book, for section 7.2, read the pages there. Also where to find some extra videos in Canvas that have been put up for you. I'm just going to go straight into here the KnewtonAlta homework. Now, you're not going to see the word preview, right? You're just going to see the title and the mastery bar telling you how much has been completed. The there's a question and what objective that question is on. And if you click on the down arrow here, you get all the objectives that are in this assignment and what progress you've made on all of them. All right. So before I get into this particular objective here, I want to talk about because all these objectives are pretty similar. So I want to talk about what are called the 6 trigonometric ratios, right, on a piece of paper here. Okay, so the trigonometric ratios, these are, you're dealing with right triangles only for right now. Remember what it means for a triangle to be a right triangle. Right? A triangle that's a right triangle has a 90-degree angle in it, right? A right angle, or a pi over 2, right? Pi divided by 2 radian angle. Right, and then there's, 3 sides as a triangle. Let's say the angle measures have names. So there's, there are angles here. There are actually, three sides and 3 angles. Let me call this angle here angle alpha. Like I said in a previous video, the angles will be named by letters or Greek letters. This is the Greek letter alpha. And let's say that this angle up here is named beta. All right. Now if we focus on just one angle, all right, so say we focus on angle alpha here. Let's put our focus on angle alpha. First off, it's an acute angle. All right, remember, an acute angle measures between 0 and 90 degrees, right? So less than 90 degrees. If we focus on angle alpha, then we can name the side lengths in certain ways. Right? The side that doesn't form angle alpha, right? You see how these two sides, right? These two sides form angle alpha. The side that doesn't form the angle, the side on the the opposite side of the triangle, this side here, right, is, we'll call it the opposite side. This is opposite angle alpha, right, the opposite side. This side here, that's part of angle alpha, that helps form angle alpha. This side will be called, it's touching angle alpha and it's near angle alpha. This is going to be the adjacent side to angle alpha. Adjacent to angle alpha. Now this other side is also touching angle alpha, right? It's also adjacent, but it's given a special name, and you may have heard this before. The side that's the largest side in a right triangle, the side that's opposite the 90-degree angle, this side is always given the name in a right triangle, the hypotenuse. Right. So no matter what, right triangle you're looking at, the side opposite the 90-degree angle is called the hypotenuse. Okay. So again, focusing on angle alpha, you have side opposite, the side adjacent, that's touching it, but not the hypotenuse, and then you have the hypotenuse. All right, so now we get into the definition of these, what are called the trigonometric ratios, or the trigonometric functions of angle alpha. So that's trigonometric. I'll say trig a lot for trigonometric or trigonometry. The trigonometric ratios of angle alpha. Right. There are 6 of them. Right. I'll name them all. Right. And this will actually kind of cover all of the objectives, all 3 objectives, kind of in the same time. So the first one's called that we're going to learn about is called the sine of angle alpha, S-I-N-E. Right. And the notation for it is 3 letters, S-I-N. And as I was saying before, these trig ratios are sometimes referred to as the trig functions. So if you recall from like pre-calc 1 or any algebra class you've taken before, remember function notation like f of x, g of x, stuff like that, where you have a set of parentheses and then an input? Same thing here. This is like the name of a function, like f or g, and then in parentheses you have an input, and the input is the angle that you're talking about. So if I want to to tell me what the sine of this angle is, all right, the sine of alpha. All right. So this is the sine of alpha, this angle. And the way it's defined is the side opposite. So it's the length of the side opposite, right, the length of this side, divided by the length of the hypotenuse. Okay. All right, so that's called the sine. Next, the cosine of an angle. Right, and again, it's the name of the function when you write it in function notation is abbreviated with 3 letters. It's COS. This stands for cosine of, and then in parentheses you have your input, and the input is again some angle measure, and we're focusing on angle alpha right now. So I put the cosine of alpha, and the way the cosine of an angle is defined in a right triangle, it's the side adjacent. Right? It's the length of the side adjacent divided by, so the length of this side, right, adjacent to alpha, divided by the hypotenuse, right, the length of the hypotenuse. All right, the third one, the third trig ratio or trig function that you'll be using a lot of, is called the tangent of an angle. Right, tangent. And when you write out the notation, the function notation, it's abbreviated just TAN, right, 3 letters. And the input is again this angle that we're focusing on, the angle measure alpha. All right, and the tangent of alpha is defined to be the length of the opposite side, right, the side opposite alpha. So again, the length of this opposite side of alpha divided by the length of the adjacent side. Right, so the length of the adjacent side, the one touching alpha, that's not the hypotenuse. Okay, well, then you have what are referred to as the reciprocal ratios. because they're just the reciprocals of these three. Alright, so if you know the sine of an angle, the sine of alpha, you know the cosine of alpha, you know the tangent of alpha, then these, you just flip these over, you take the reciprocals, and you'll get the following three. Alright. So the fourth one, the fourth trig ratio, is I'm going to do this is the reciprocal of sine. Alright, the reciprocal of the sine is, and again, now where some of these names come from, you'll get to in a later section. But the reciprocal of the sine function, or the sine ratio, is called the cosecant. Cosecant. Right. And it's abbreviated when you write in function notation as CSC. Cosecant. Right. And again, the input is some angle measure. We're talking about, we're focusing on angle alpha here. And as I said, this is the reciprocal of the sine. So the sine ratio was the side opposite divided by the side that's the hypotenuse. You flip that over. Right, so the cosecant of that angle alpha is the length of the hypotenuse divided by the length of the side opposite of alpha. Right, the next one is the here we have cosine of an angle was the length of the adjacent side divided by the length of the hypotenuse. If I flip that over, do hypotenuse over adjacent, that's called the secant of the angle. Right? This is the trig ratio called the secant. And in function notation, this is abbreviated SEC. Okay, so SEC of alpha. Right? You always have to have this input. Right? Again, like I said earlier, it's just like function notation. You can't just write f. You need f of x. You need to know what the input is. Right? Same thing for all these. You can't just write the three letters. You have to write what the input is also. What's the angle that you're taking the secant of. And as I said, it's the reciprocal of the cosine. So the length of the hypotenuse divided by the length of the side adjacent to angle alpha. All right. And then finally, we had the tangent of an angle. The tangent of an angle is the length of the opposite side to the length of the side adjacent to that angle. That's not the hypotenuse. Flip that over, and you have adjacent over opposite. And this trig function, this trig ratio, is called the cotangent. Alright, and it's abbreviated in function notation by three letters, just like all the other ones, as COT. And then you have an input, right? And the input is the angle. The angle we're talking about here is alpha, again. And if the tangent of alpha is the opposite over the adjacent, then the cotangent of that same angle is the length of the adjacent side divided by the length of the opposite side. Okay. So these are called the 6 trigonometric ratios, the 6 trigonometric functions for an acute angle, right? For an angle in a right an acute angle in a right triangle. Right. And you may have seen this in some other class before. I don't know what you've done in your life, but there's an acronym, a little device to help you maybe remember these. You might have seen this before, SOHCAHTOA. It's a fancy sounding word. Doesn't have really any meaning as an English word, but SOHCAHTOA. Say that out loud a bunch. SOHCAHTOA. And these stand for the sine of an angle in a right triangle, an acute angle in a right triangle. The sine is the opposite divided by the hypotenuse. So ka, the cosine of an acute angle in a right triangle. The cosine is the adjacent side divided by the hypotenuse. And then TOA, right? The tangent of an angle in a right triangle is the opposite length divided by an adjacent length, right? The adjacent length. So you might have seen this before. Okay, and again, if you can remember these three, just flip them over and you'll know these three. But people tend to forget, people tend to mix up the names, right? And I get it, there are 6 of these names. It's probably pretty easy to mess them up. But the reciprocal of, sine, cosecant, right? The reciprocal of cosine, just regular old secant. And the reciprocal of tangent, cotangent. Right, try to get those down. Right. Okay, so let me go back to the here and now. Like I said in my previous videos on section 7.1, I'd recommend that now if you've done the OpenStax reading and watched the videos, taken notes and all that, and practiced some stuff, and you feel comfortable with the material, I'd say start answering questions right now. But if this is the first time, or if you're still unfamiliar with this stuff, what they're saying here, evaluate reciprocal trig functions using right triangles for a sine, cosine, or tangent function. If you're unfamiliar with what that means, I'd say click on, the first time you see a new objective, click on more instruction and get through the assignment with more instruction. So now I think there's a video here, yeah. So I'm not going to show you this video, all right? Yeah, and then and then you continue, and like I said, I've already explained a little bit. All right. Now here it's asking to determine the cosecant, secant, and cotangent of the angle B, right? So pay attention to what angle they're having you focus on. That's this angle right here. All right, so I'll do this on some paper. Okay, so I've drawn a picture with the same right triangle, right, a right angle. And they asked us to find, the values of some trig functions, trig ratios of angle B, right? So I'm focusing on this angle here, right? This angle here, this amount of turning here, right? So if I'm focusing on angle B, that means that this this side here with a length of 4 units, right? That's the side opposite angle B. This side here, that's that's touching angle B, that forms angle B. That's not the hypotenuse, right? The hypotenuse is always the side opposite the 90-degree angle in a right triangle, right? That's the hypotenuse. And then this would be the adjacent side. Now the adjacent side, I don't know, right? Let's call it X, right? Let's call it X, something unknown. So I would first like to find that adjacent side by using the Pythagorean theorem. Hopefully this sounds familiar as well, right? And this is probably something most people are familiar with when it comes to right triangles. Remember, in a right triangle with side lengths A, B, and hypotenuse C, the sum of the squares of the legs, right, the two sides that form the 90-degree angle, is equal to the hypotenuse squared, right? So you can use the Pythagorean theorem to help you find missing side lengths, right? Because I know that the side opposite angle B is 4 units long. I know the hypotenuse is 8 units long. I just don't know the length of this adjacent side. So again, I'm calling it X units. Let's say this is X units long here. So according to the Pythagorean theorem, the sides that form the 90-degree angle, add those squares up, x squared plus 4 squared should be equal to 8 squared, the hypotenuse squared. And then we solve this for x. And we have x squared plus 16 equals 64. Subtracting 16 from both sides would give me x squared equals 48. Right? 64 minus 16. And so x equals, now technically you would say positive, or you could say positive or negative square root of 48, but we're talking about side lengths here. These are lengths of sides, so we're only going to work with the positive one, the positive square root of 48, which you're gonna have to remember how to do some algebra junk, right? Simplify radicals, simplify roots. This is the square root of 16 times the square root of 3, right? And the square root of 16 is 4. Alright, so the length of this side, this adjacent side to angle B, is 4 times the square root of 3. Alright, now that I have all three lengths, the side opposite angle B, the side adjacent to angle B, and the hypotenuse, I can find the values of all 6 of these trigonometric ratios. So I'll put those down here, and I'll do all 6 for this. I know they only asked for the reciprocals, the cosecant, secant, and cotangent, but the trig ratios of angle B. This is the angle symbol. Trig ratios of angle B. Right, so remember the sign of, and remember in parentheses after the word after the name of the function, you need to have an angle, right? The sign of what angle? The sign of angle B equals, and I'll just put OPP for opposite, divided by HYP for hypotenuse. So the sine of this angle in this right triangle is opposite length 4 divided by hypotenuse is 8, and you're going to have to reduce things and rationalize denominators and stuff like that. This is 1/2. Right? The sine of angle B is 1/2. So that means the cosecant of angle B, right? Remember these are the reciprocals, sine and cosecant. That's hypotenuse over opposite, is just, instead of 1/2, is 2/1, right? Or just 2. Right? So this is one answer, right? They did ask me for in the problem there, they asked me for the cosecant, so that's one answer. Right. Next one, how about the cosine? Right, I did the sine already. The cosine, COS, of, and again, you need to have an angle after it, right? An angle in parentheses. It's a function. I need to know what the input is. Well, the cosine of an angle, right, is the length adjacent to I'll put ADJ for adjacent, divided by the hypotenuse. All right, so that's, let me separate these here. Adjacent length, the side adjacent to angle B was at 4 times the square root of 3, divided by the hypotenuse, had a length of 8. And again, you can simplify this. There's a factor of 4 up here. This is 4 times 2. 4s would go cancel. This is just the square root of 3 in the numerator divided by, 4 goes into 8 twice. The square root of 3 divided by 2 is the cosine of angle B. So the reciprocal, remember the reciprocal of cosine is called the secant, SEC. The secant of angle B is, again, hypotenuse over adjacent, right? Just flip this over. Well, if I flip this over, right, square root of 3 divided by 2, the reciprocal is 2 divided by the square root of 3. Now, in most cases, they're going to have you rationalize the denominator, right? You don't want, remember from algebra class, right? You don't like square roots in the denominator for some reason. So I would multiply the numerator and denominator by the square root of 3. You have 2 times the square root of 3 in the numerator, divided by the square root of 9 in the denominator, which is just 3, and there's a rationalized version of that same answer. And they asked for this, right? What's the secant? So this 2 times the square root of 3 divided by 3. Then finally, right, the only other one I haven't done yet is tangent and cotangent. Right? So I'll uncover these in a second. Remember the tangent, TAN, of an angle. Right? Again, you need the angle to tell people what's going on. What's the input? The tangent of angle B, well, the tangent of an angle is the length opposite, right, OPP, divided by the length adjacent. All right, so in this triangle, the tangent of angle B is opposite 4 divided by adjacent to angle B is this 4 times the square root of 3. All right, so you see the 4 is canceling. This would be just 1 divided by the square root of 3. And then just as in the previous problem, when I did secant, I'm going to multiply the top and bottom by square root of 3 to rationalize the denominator. So I have 1 times the square root of 3, or just the square root of 3, divided by 3. Alright, so that's the tangent. So the reciprocal, right, remember the reciprocal of tangent is called cotangent, COT. So the cotangent of angle B, right, is just the reciprocal of that, adjacent over opposite. Now I could flip this over, I could flip this over, and I could flip this over. Now if I flip this last one over, there'll be a square root in the denominator. I don't want that. I'm going to flip this one over. 1 divided by the square root of 3, when I flip that over, is the square root of 3 divided by 1, which is just the square root of 3. All right, so the cotangent, reciprocal of tangent, right, is the square root of 3. So I have my values, right? The cosecant of angle B would have been 2. The secant of angle B is 2 times the square root of 3 divided by 3. The cotangent of angle B is just the square root of 3. And it all started, right? You know, in order to do this in a right triangle, right, this is only for right triangles, you need to know all 3 sides. So if they only give you 2 of them in a right triangle, right, you're going to have to use the Pythagorean theorem to find the 3rd side. All right, so let's go back to the assignment. Now, oh, this was a multiple choice. So we said, you know, cosecant was 2, secant was 2 root 3 over 3, and cotangent of angle B was square root of 3. That's this first option right here. Wonderful. And then they go through the explanation. Well, they show a video here, but okay. All right, so then another video involving, you know, secant, cosecant, and cotangent. And then we continue on and get another question. All right, now here, this is one where all, you know, the three side lengths are already given. All right, the 3 side lengths are already given, so that makes it a lot easier, and it's a right triangle. Okay, so I drew that again, right? I drew the same picture they had there. And they asked us for the secant, SEC. What's the secant of angle B? All right. So notice the angle measure there is, the angle we're focusing on is angle B. So I'm going to like put a little bubble around that or something, or mark it off. That's the angle I'm focusing on. So if that's the angle I'm focusing on, then this 35 is the side opposite, right, OPP. This 12, this side with a length of 12 is the adjacent, ADJ. And the side opposite the 90-degree angle is always the hypotenuse, HYP. Right? Now remember, secant is the reciprocal of cosine. And what was the cosine of an angle? All right, the cosine of an angle is adjacent over hypotenuse. So the secant is the reciprocal of that, hypotenuse over adjacent. So angle B, the hypotenuse is 37 in the numerator, divided by the adjacent length is 12, and that's as simple as that gets. 37/12 would be the secant of angle B. Right, and so enter your answer as, and read the instructions, right? Enter your answer as an improper fraction if necessary, and only enter the numerical value, right? Don't punch it in your calculator or anything. Right? It doesn't say to round to anything, right? So 37/12. Great. And then, right. Another video, blah blah blah. All right, now we're out of the instruction. Okay, and here we're use right triangles to evaluate sine, cosine, and tangent functions. Right. So again, you can click on more instruction if it's the first time you're seeing it, or if you're confused. Right. Click on more instruction. I'm just gonna do this on paper right now because I've already shown you all 6 trig ratios, and every objective here is related to those 6 trig ratios. So I'm not going to click on more instruction, but again, if you want to, you can. Alright, so I've drawn that picture. There's a right triangle. The only angle they have named is this angle here. Alright, so that's the one we're focusing on. Alright, angle theta. That's pretty faint, sorry. Alright, so is that, but this is the angle we're focusing on, angle theta. That's the Greek letter theta. So this 9 here, right? That's the length of the side opposite. 41 is opposite the 90-degree angle. That would be the hypotenuse. And the 40, that's the side adjacent, that forms the angle but is not the hypotenuse, right? So that's the side adjacent. Now, for this particular problem, all we're asked for is the cosine of theta, right? So what is the cosine of theta? Right. So remember, the cosine of an angle is the length of the side adjacent divided by the length of the hypotenuse. Side adjacent is 40, right? Adjacent to theta, and then the hypotenuse has length 41, and that's all we're asked to enter. Is just enter the it says enter the answer as a fraction. All right, so 40 over 41, 40 41sts, right, whatever that number is. Okay. All right, so here's again, just evaluate trigonometric functions of angles not in standard position. This is just they're drawing right triangles that aren't flat on the screen. They aren't horizontal. Right, you see the right triangle they have here, how one of the sides isn't horizontal. That's all really this objective's on. All right, so again, you can click on more instruction if you wish. I've already talked about it. I'm just going to draw this and do it on paper. Okay, so I've drawn this right triangle, that picture they had. We're asked to find the secant of theta. Right? So that this is the angle we're focusing on up here, this angle theta. And if that's angle theta, then this side length over here, that's not forming angle theta, is the opposite side, right? So the opposite side has a length of 7. The side that's opposite the 90-degree angle is always the hypotenuse in a right triangle. And so then this side here that forms, helps form theta, but is not the hypotenuse, right? This is the adjacent side, ADJ, that has a length of 24 units, and the hypotenuse has a length of 25. And they're asking us for, what is the secant of theta? What is the secant of theta? Well, remember the secant, I've mentioned this already, this is the reciprocal of the cosine. Cosine was adjacent over hypotenuse, so this is hypotenuse over adjacent. So hypotenuse is 25 units divided by the length adjacent to theta is 24 units. And that's it. All right, 25 24ths. And this says enter an exact answer in fraction form. Right? So just enter the fraction 25 24ths. So here's another one again. When they say not in standard position, all it means is that you're going to be looking at a right triangle where none of the sides are horizontal. All right, just a weird looking right triangle. All right. So again, I'll just draw a picture and show you. All right. So here's this one. And again, we're focusing on, the only angle that's named in here is angle theta. All right. So if this is theta, this side with a length of 12 is the opposite side. The side that's opposite the 90-degree angle is always the hypotenuse. And then the other side that's also forming theta is the adjacent side. This time we're asked for the cosecant of theta. So CSC, that was cosecant of theta. Now this one, right, the CSC, cosecant, this one's the reciprocal of the sine function. All right? And the sine of an angle was the opposite divided by the hypotenuse. So the cosecant is the hypotenuse divided by the opposite. Right? Just flip over the sine. The length of the hypotenuse here is 13 units. The length of the side opposite angle theta is 12, right? So we're going to enter 13 twelfths. Wonderful. All right, so this one they're asking for sine of theta. Now hopefully, I'm just going to point this one out because all the side lengths are again there. I'm just going to point this one out with my mouse, my cursor, and hopefully you can figure it out. They're asking for the sine of angle theta. So theta's here, right? What am I doing? Theta's right here. So the 35 length is for the opposite side of theta, right? The 12 length is for the adjacent side to theta, and the 37 length is opposite the 90-degree angle. That 37 is the hypotenuse. Remember, the sine of an angle is the opposite length divided by the hypotenuse. So the opposite length is 35, the hypotenuse is 37. So 35 divided by 37, 35 over 37. Simple as that. And again, please get to memorizing these trig ratios. Make it a little easier for you. We'll make it quick. So again, I'm going to just leave it the way this is and move my cursor around. Hopefully you can follow my cursor. We're asked to find the cosine of theta. So it's again a right triangle. Here's theta, this angle that's marked off down here. The opposite length is 5, the adjacent length is 12, and the hypotenuse is 13, right? The side that's opposite the 90-degree angle. And the hypotenuse should be the longest side of a right triangle as well. Cosine. The cosine of an angle is the adjacent length, 12, divided by the hypotenuse, 13. Right? So this is 12 thirteenths. So here's another one. Now, so far we've been very fortunate. They seem to give you a lot of problems where all three sides are known. Remember, if there's a side missing, you have to use the Pythagorean theorem to find it. So another one where we're asked to find the cosine of theta. So here's theta. The opposite length is 20. The adjacent length would be 21. The hypotenuse, right, side opposite the 90-degree angle would be 29. Cosine, COS, cosine of an angle is adjacent over hypotenuse. So 21 over 29, 21 29ths. Alright, this one I'll write out because I haven't written out the tangent too much. Alright, so I'll go to a piece of paper. Alright, so here I am on draw the same picture. They asked us to find the cotangent of theta. So theta's here, right? This angle is one we're focusing on. So the length of 5 units, that's the length of the opposite side to theta. 12 units is the length of the adjacent side to theta, and 13 units is, the longest side, the side opposite the 90-degree angle. That's the hypotenuse. Right. Now the cotangent of theta, COT, this is the reciprocal. This is the reciprocal of tangent, the tangent ratio. Now tangent of an angle in a right triangle was the opposite length divided by the adjacent length. So flip that over. The cotangent will be the adjacent length divided by the opposite length. So for theta here, that's 12 for the adjacent length divided by 5 for the opposite length. 12 fifths. It just says enter as a fraction. Right? Alright, yet another one. Alright, so this time, again, I'll just point it out with my cursor. We're asked to find the cosecant, CSC, cosecant of theta. This is the reciprocal of the sine. Remember, the sine of an angle is opposite over hypotenuse. So this is hypotenuse over opposite. So here's theta. The hypotenuse is 25 units long. The opposite angle theta is 24 units long. So 25 over 24. Hypotenuse over opposite for cosecant, right? The reciprocal of sine. All right, here's one where again all three sides are known. So we don't have to use the Pythagorean theorem. Here's angle theta. We're asked to find the cosine of theta. Remember, cosine is adjacent, so 24 over hypotenuse, 25. So 24 25ths for the cosine of that angle. And this time we're asked for the cotangent, COT, right? TAN is tangent. TAN, tangent, is opposite over adjacent. COT, cotangent of an angle, is adjacent over opposite. So the cotangent of this angle is adjacent, 24, over opposite, 7. Right, and I think that'll be all for this section, yes. Alright, so again, get those 6 trigonometric ratios down. Please have these, it would be easier if they were just memorized. Right, if you just memorize these ratios, right, and which ones are reciprocals, right? Sine and cosecant are reciprocals, cosine and secant are reciprocals, tangent and cotangent are reciprocals. Maybe SOHCAHTOA TOA will help you. All right. Whatever you need to do to remember them, please do it. All right, so that's it for 7.2 part 1. And hopefully it was helpful. Again, you're not going to see exactly the same stuff I'm seeing, but the objectives are the same. The way you do the problems are the same. All right. You just might see some different numbers or things in a different order than I did. All right. So thank you for watching.